Hey everyone, this is Aage here with an F-sharp exercise for you. I'll just share my screen real quick and I'll introduce myself properly. One sec. Share. Just going to turn off my cam. So today for Functional February, I'm going to do an exercise. I'll introduce me real quickly. My name is Aage Ten Hengel. I live in the Netherlands. I'm a lead developer at Tenair.com, where we do business marketing software. My main interests are test automation, team flow, security, build and release pipelines, and functional programming, of course. And in my capacity as a mentor of C# and F# right now, I'm giving you this little demonstration right here. So who is this for? Well, I wanted to attack this from a beginner level, but I expect you to have at least a little bit of development experience. And if you want to have a look at functional programming, this would be a great opportunity for you. Or if you're already well versed in functional programming and you would want to see some idiomatic F# syntax. What are we going to be doing today? The Pangram exercise on the F# track. We'll have a look at that later. I'll be talking about some unit testing strategies, the difference between imperative versus declarative code, honest versus dishonest functions, and we'll be looking at some partial application and what that entails. I'm running on a Windows 10 machine on Visual Studio Code. The exercises are now in .NET 7, and I'm using the extensions Ionide and Fantomas. And Ionide turns Visual Studio Code in a good IDE, and Fantomas helps me format code nicely. So let me just switch to my browser where we'll look at the exercise. I'm here in Exercism in the F# track on the Pangram exercise. What is the exercise? We want to determine if a sentence is a pangram. What is a pangram? A pangram is a sentence which uses every letter of the alphabet at least once. An example of a famous pangram. And it's important to note that we're looking at a case-insensitive implementation. Okay? So normally when I start an exercise, I would copy the link right here and then jump to my Visual Studio and then get the source this way. But since I've already submitted a working solution, I've basically reset it to the beginning of the exercise, how it is when you first take a look at it. So what do we see here? We have a pangram.fs file, and we have a pangram tests file. And we see that the signature is already written out for us. We're going to make a function that takes a string as input and returns a Boolean as output. Now, in F# you can do this explicitly like this, which is recommended when you're writing a public-facing function. The compiler could also figure it out for you. It's going to fail right now. It's going to throw an error, so it doesn't have an implementation yet. And I wanted to touch upon a subject called a dishonest function. Right now, this function says it will return a Boolean and it takes a string, but as we can see, it would actually throw an exception right now. Within functional programming, a lot of developers try to emphasize the importance of an honest function. Why do you want an honest function? Well, you want something to do what it says it does. Another example is, let me just type something up. Let's say you make a function that divides A over B. And the interface is visibly here to the right. So it takes an int, it takes a second int, and it returns an int. But in fact, this also is a dishonest function. Now let me just throw this to F# interactive. I'm still highlighting it and then hitting Alt-Enter. And now at the bottom of my screen, a little REPL will open up where you can immediately test some stuff out. So I've sent the divide function to this to the F# interactive window, and we can test it like this. So divide 10 over 2. I need to provide 2 semicolons to execute and return 5 as expected. But when I divide by 0, we will get a divide by 0 exception. Now, if you have some experience within .NET Framework, this probably won't be a surprise to you. And when you're working in object-oriented programming, this might even be accepted for you. But within functional programming, we want to make functions that literally only return what they say they will return. Now, what would be a way of making this an honest function? So in this case, I might want to take into account that we cannot divide by 0. So let's say if b equals 0, then error not good, else return okay. Sorry, I don't need a return statement. It's my C# coming up. A over B. Not 1 over B, but A over B. So now the signature of this function changes. It still takes 2 integers, but it will return a result of int and string. And the string stems from the error type I've provided right here. Now, what would be the difference for a caller? So let's say if the divide function was still in its old implementation. So I would maybe say divide 2 over 1. In the old implementation, this would be an int, but now it's a result of int and string. So this now forces me to take into account the fact that that function can fail. And we want to deal with that at this moment and not be able to, not be expected to rather, have a general exception handling encircling our entire program that deals with this kind of stuff. So now I could do something like this, do some pattern matching, and say, okay, is it an error? Then I'll do something, or is it an integer basically? So you see here, the error is of type string, and the OK is of type none. That's just a little side note for you on what's the difference between an honest and a dishonest function. Let me just remove this real quickly, and let's actually start with the exercise. So we need to write an implementation. We need every character in the alphabet, and it needs to be lowercase, not lowercase, but case insensitive. I think those are the 2 most important specs. Let me just check. Yeah, case insensitive. So that's it. And let me just start writing some code. Now, what I thought I'd do is I'll first start with a more imperative implementation. And what does imperative mean in the context of programming? It means that I, as a developer, will tell the code what to do. So here you can think of for loops where you iterate over a list of numbers, and for each number you do something, you change something outside of that for loop. And within OOP, a for loop is very much accepted, but within functional programming, it is considered to be not desired and maybe even impure. And maybe I'll explain later what that really means. But F# within the spectrum of functional programming languages is a bit unique in that it allows for impure code, for mutable code, so to speak. So we can write a implementation that would be similar as you would write an implementation in a non-functional, object-oriented language. First, I'll show you a neat little trick within F#. So where in other languages you might have to specify each and every character in the alphabet in a list, within F# you can do this, where you just take a range from A to Z and you have the alphabet right there. So this is more or less our expected statement. Within this code, we want our input or all the letters in our input to resemble this alphabet when looked at in a unique manner. I'll just start writing a little loop right now. So for character in input, do, and now I can do something within this for loop. You see that it doesn't use brackets or anything, no accolades. That's because F# has a significant white space. So the fact that I just tabbed forward means that everything I do now is within the scope of this for loop. And what I can do is do something like this. Or do lower. Now, what I want to do now, for this moment, I would like to add it to some kind of list where I keep my results. So let's say that cars is list. So it's just a list right now. It's not typed yet, and I might want to add this lowercase character to this list. So let's see if I can do that. Now, we see a couple of things. First of all, there's a red squiggly line. We do not want that. Let's just see what it says. It says this value is not mutable. And what it's talking about is this list of character in this case. I mentioned that within F# you can write impure code, but you have to be explicit about it. So you cannot do it by accident. So right now I've just added this mutable keyword, and which means I can set something in this variable basically. And what I've done here with the double colon is I've prepended the result from the lowercasing of the current character to the list of cars, basically. And prepending it like this has a better performance than appending it, which takes a list, but you could do it like this. So you notice that this is a different operator. This concatenates two lists together. And what I had before prepends a single value to that list, and it has to be of the same type. So now I have basically a lowercase version of every car in the list, in the input basically. But since we're only looking for every character in the alphabet at least once, and that's the thing that we're comparing against, we want to make this unique. So let's say we can do that. Unique is, I'm going to take these cars, I'm going to pipe them to a function on the list module. I'll explain what I'm doing right now. So this cars variable is a list of characters, which means I can use every function in the list module on this list. Now the filter function, as you'll see right now, you can't see. You'll see right now, it takes a predicate and a list, and it returns the list. Now by already giving this function, it takes a character and returns a Boolean, when that character is a letter. By already giving this function to the filter function, it would build a new function out of these two, and that's what I'm piping the collection to. So let's say I want to write that out first, just to show you what stuff like this can do. So right now, here I've got written out a local filter function, which just takes a list of characters and returns a list of characters. And that has the isLetter predicate baked into the list filter function. But it's also very common to do it just like this. I can just change it like this. And earlier I was mentioning partial application, and this is exactly what partial application is. So you have a kind of generic function list filter, and I'm making it more specific by providing its first argument. And by providing its first argument, it returns a new function which I can then use. And this creates this nice pipeline in which I can chain functions together to get a desired result. I'm going to clean up this right here. So now the characters should be only letters. Of course, we want to have them distinct because we're checking against the alphabet, which features every character only once. And that wouldn't be enough still because the order might be different. So I can just apply a sort like this real quick. So now we have a unique list of the characters within the input, and the only thing that is left is to compare these two, and this should be enough, but we'll find out in a bit when we look at the unit tests. Clean up this. In the end, we don't need a return statement, so this is basically an expression. So implicitly, this is returned from the isPangram function, and it compares these two via structural comparison. So if they are the same, have the same contents, they are considered to be the same. And within C#, for instance, you would have to write this out explicitly, but because it will first hand compare the references, if they are the same reference in memory, they would be considered the same. But you don't have to do that within F#. So we now got a first implementation of this function. And I just want to go ahead and take a look at the unit test right now. I'm just going to slide this over to the right. And now in my left window, you can see the unit tests. We're using XUnit, which is pretty much standard within .NET nowadays. And just forgot to mention that when I just pulled this source to my machine, I did a .NET restore. So every time you do an exercise like this within C# or F#, it's expected of you of just you do a .NET restore. It will load up all its dependencies, and if you just want to figure out if that worked, you can do a .NET build after that, and it should build, even though you don't have a working implementation yet. Now I want to talk a little bit about unit testing strategies. We have a set of 10 tests here, and the first test is enabled and the rest is disabled by providing this skip statement in the fact attribute. And of course, I could do this, solve this exercise very much test-driven. So the red-green refactor cycle, make a test that fails, supply enough code to make the test pass, and then refactor, and so on and so on. But since this is basically quite a simple exercise, I usually just enable all the tests at once and run the entire set. So that's what I'm going to do right now. Just copy the skip statement and I remove them all. Let me save that. And now within the terminal, I can fire a .NET test command. And luckily, they all pass. So here in the bottom, it says pass 10, and the color is green, which is very much a relief. Now, we aren't done quite yet, because I want to show you the difference between more imperative versus declarative code, which I'm going to do right now. And with that, I also want to get rid of the for loop and the immutable state right here. So let me just figure out what we can do. The alphabet can stay. This is our expected case. So let's try to write this in a more functional way. I'm just going to comment that out. It means I need a new unique variable. And now I'm going to take the input and I'm going to pipe that directly into another function. I'm going to use the sequence module. You might think, well, how can we pipe a string to a sequence module? That's because within .NET you can iterate over a string. So if you're coming from C#, for instance, a sequence is more or less the same as an enumerable of T. So I can use all the functions within sequence on a string as well. Now, like we did before, I want to do some filtering. I'm just going to filter for letters right now. Then I'm going to do a map. And what is a map? Again, if you're coming from C#, this is the equivalent of select within link. So I have a sequence, and each thing within the sequence I want to map from A to B, basically. This I can also provide a function with. This I can also provide a function too, I mean. Just need the hard to it lower. Now we have a sequence of characters. Like before, I want to distinct this. And I want to sort it. And because our expected state, or expected case, the alphabet is a list, I want to turn this into a list as well. Do a list of sequence, and now the two types align. And let me just check if our unit test still passed. So now we know for sure we haven't broken anything in our refactoring right here. Let's see something in chat. No questions yet. If there are any questions, please let me know. So now we have a more functional way of writing this code. We got rid of the for loop. We got rid of the mutable state, and just to drive home the point of this being declarative, instead of writing a loop where we want to say you need to do this for every element within the loop, we're just saying for everything within this collection, I just want the character to lower if it's a letter. So you're less focused on implementation details. You're less prone to be hit by off by one errors, where you determine the index based on the length of the collection, and you want to write a loop till the index or the length of the collection -1, that sort of thing. And you can just focus on what you want out of this. Now, we've seen that it still passes the tests, but I think we can clean up this even a little bit more. I'm not so keen on the distinct and sort functions right here. And I think we can use a collection within F# that will take care of that for us immediately. So we initiate the list of characters like this, but within F# there's a type called set, and within your language of choice, you might be familiar with a hash set. I think that's in Java as well as it is in C#. And a set is basically the same. So it is a distinct set of elements, where each element only occurs once. And we can turn this alphabet into a set like this, with a set of list function. And now we just need to compare that to our unique result right here. But as you can see, we have more red squiggly lines. So that's something we need to do. Basically, what we can do is replace this block of 3 statements and combine them into one. So we already have a sequence of characters that we want. So I think this should be enough for now. The result of the sequence.map, it won't be unique, but when I add an element to a set twice, it will just keep one of them. So it will do the distinct and the sorting for me. think this looks pretty nice. Let me just run a test again, see if we're still passing, and we are still passing. Yeah, and I think that's pretty much it. Concerning this exercise, I'm pretty happy with the solution, and I wanted to give you some more tips before I take off. If there are any questions, please send them in chat. I'll just switch back to my PowerPoint real quick. 1 second. Oh, 1 second again. That went wrong. Let me hit the. Okay. I want to give you some recommendations. If you're coming from C# and want to use functional programming within your job, but can't get everybody around using F#, there's a really excellent book called Functional Programming in C#. It's by Enrico Buonanno, which I can really recommend. I've learned a lot from him. Within F#, one of the people to go is Scott Lashin. He has a site called F# for Fun and Profit, which features a lot of tips on using F#. He also has a nice book out called Domain Modeling in F#. And of course, you could join us within Exercism and join a functional track. Like I said, I'm a mentor on the C# and F# tracks, and there's a lot of nice functional tracks out there with mentors keen on helping you, and you're more than welcome to join us over there. So that's it for me for now. Maybe I'll see you soon, and have a great day. Bye-bye.